Hi, this is Antminer Repair, and got my soldering gun back, so we're gonna try to do a couple videos. Somebody on YouTube asked, "Gee, could you show how to put resistors back on?" Now there are videos on YouTube that I learned from to do this. However, there's a little bit more to it than just putting resistors back on. I guess if you catch them, I guess if you catch them when they fly off, or find out what heat sink they flew under or where they stuck to on the board because you've overheated the chip and the board a little bit. And goodness gracious, I've been guilty of that. I'm looking at one right now on the screen. Um, you need to put them back on, but what happens if you lose the resistors? So tonight, I'm not only going to show you how to solder. I'll just do one. I'll just do, this resistor right here that goes here on this. This is the RO port, actually, the one that comes backwards across the chips. I'll not only show you how to do that, but I want to show you resources on how to tell what capacitors are which and what resistors are which. And it's kind of a journey that I had to go through with a board that I fried a bunch of chips, so I took off all the heat sinks, and I just sat there night after night with a digital microscope, figuring out where all the circuits went and looking at numbers, looking at all the different parts of it. So if you like this content, please subscribe. Also, if you want to get notified when I push out videos, there's two ways now. If you're on my Discord or on the Discord, it's not necessarily mine. It's I don't want to claim ownership to it. I'm just hosting it. There's a Discord channel. I post the new videos there, and there's a lot of conversation going on there. And I want to show you a couple things before we get into this. Or YouTube, if you hit that bell right in front of you, that will tell you when I publish a new video. There's a couple links up there, one to PayPal, one for Bitcoin. If you'd like to donate to this cause of trying to get the word out, it helps me buy supplies and all sorts of stuff just so I can work on these things for you. All right, so I'm going to do a quick, real quick commercial and kind of show you our progress on Discord. So let's have a look at that real quick. Don't switch and no. Okay, so you should be looking at Discord. This is the invite link. This will be on the description of the video you're watching right now. I highly recommend. We started this like 3 or 4 days ago. Already got 24 members in here. Great stuff. I just want to show you a couple things. Hashboard repair. People are posting circuits. People are posting where to get resources, pictures of circuits, discussions, hey, what this chip is. So I really highly recommend this. Diagnosing problems. You can actually ask questions, say, I'm having problems with this. There's a couple people on here that have really, really good experience. I'll always try to answer something, but they pop in too. Discussion about immersion, a crypto news channel. So there's just a lot of good stuff. And if we build this community, I think it'll be beneficial for the people repairing things. We've got a few people on here that are actually going to the Antminer classes on how to repair it. So they're going to be great resources for this. This is for learning. It's not for cutting people down. So end of my commercial. So that's that. So let me stop that, and let's go back and talk about the resistors. So the first question is, when you have to replace the resistor, is what size was it, and how many volts was it, and how do I do that? So there is a document. I've gotten it off Zeus Mining, and I'm going to show it right now. Let me get to it. And I want to spend a lot of time a little bit later on these documents. This actually is an ASIC chip, and it's the same ASIC chip. There's two modes. They're on the board the same way. You have ground on the bottom and positive on the top for the bottom, underneath the chip. But they run either way because it sweeps this way, then it sweeps around this way. So they've actually figured out how to run the chips either way, and it work. There must be some enable thing on voltage going one way to tell it which mode it's in. But so these are on the T17 repair manuals on Zeus. I think you go to support and repair guides. They are in Chinese. They do have some mistakes in them. I think, oh, where it is. There was one, maybe it's down here. I can't find. There was one picture that identified some circuits as temperature sensors, and it wasn't. So you got to kind of be careful. But anyway, um, I like this diagram almost better than some other diagrams because I have done a computer engineering class. I'm a software guy. I understand logic. I understand pins on chips and stuff a little bit, enough to do this. So this isn't necessarily how the circuit board is laid out, but this is really a great key to finding out the sizes of the capacitors and resistors. And what I found out, because I spent a ton of time on this, is they've taken one part of the board and matched the numbers. I mean, this is actually probably the first one. They've matched these numbers, R18, 118, 119, 121, 122, capacitor 37, 20, 55. And they're actually on the board labeled as that. And the nice thing about the things on the board is they repeat the pattern over and over. So if you can locate one of these capacitors or one of these capacitors or resistors in that mode, you can look on here and say, oh, that's 107.6. That's a 1 microfarad, 6.3 volt capacitor. So they use a lot of the same stuff. You have to buy the parts, obviously, and I'll go into what I did too. They're not expensive, for sure. But today we're going to replace that lone resistor, and guess what? Look at this lone resistor. It's R120 out there. Now, if I look for that, the corresponding single resistor leaving the chip instead of the 3 coming in, here we go. This is the corresponding one leaving the chip, or it might be coming in. I'm not even sure. I can't tell which direction this is going, but it's a 33 ohm. So this is 33R. That you can look up standards for coding resistors, and it's 33 ohm. So it's 33 ohm. So that's only half the picture you have to worry about. If you look, most of these dudes are 33 ohm. They've got a couple 0 ohms. That is a place where they maybe were going to put a resistor, and now it's just a jumper block, and it's literally, you could probably put a wire across there. These aren't necessarily here. They go on the test ports sometimes, but these ones definitely are. These 3 resistors and that one, and I'll show you it on the video and what that is. In fact, I'll show you some of these numbers, which is kind of cool, and this is how I found out which ones to do. Now, I didn't know anything about, I looked at these little tiny resistors and capacitors, said, what the heck, how do I know what those are? And then said, oh great, 0.1 microfarad, I'm looking at this guy down here, 16 volt. What does that mean? How do I know it's 16 volt? Well, it turns out, at least on capacitors, a lot of times how big they are determines the voltage they can take, and these they have a size code. You guys who know electronics already know this, but the small resistors are 0201. Next size up is 0402, then 0603, maybe, I think I've got that, and then 0804. And so 804s are pretty big. These, I think actually, I didn't have anything to measure. I don't have a micrometer, so I actually went to the internet and printed off a millimeter measuring thing, and I took my digital microscope and I folded the paper and I stuck it down next to some of these and I measured them. And you have to estimate them because they're smaller than a millimeter or 2 or something, so you estimate it. Well, I estimated wrong, but it doesn't hurt anything. So a lot of these resistors, I think, are 0201s. I bought 0402s, I think, and they're a little bigger, but with resistors, I really don't think it matters. And capacitors, probably not. I mean, literally, if you blew this off with a hot air gun, you would probably be able to still run it. The way these kind of work, the way I've kind of rationalized what these capacitors are doing compared to the resistors are slowing down the pipe of current, maybe changing the voltage, maybe just changing the current. It's a pipe, and they're adjusting the pipe going through there. But these capacitors, they basically are taking this voltage and they're sucking the noise out of it. They don't let voltage go through to the ground, so they're all grounded. One side is ground and one side is actually the power. So they're just sucking noise because I think what happens is electricity is flowing to this chip and it's generating all sorts of noise and waves and all sorts of stuff. And these guys are just sucking out those waves. So you got this straight signal going through. So that's kind of what I see the capacitors are for. There's other types of capacitors that store power and things like that. This is kind of a typical power circuit up here. This is not next to the chip as far as I know. It might be even on the other side of the board. So the trick is, hopefully you have a board with no heat sinks and you could go hunting these. I'm going to show you right now. We're gonna look at these resistors, and these resistors are really the same as this resistor. I know these are around the chip. They're all 33Rs, and going into the chip, there's usually 3. Going out, there's 1, or vice versa. On an S17 board, it's a little bit different. They don't put them right in front of the chip because they're a little bit, they're a little bit different on real estate. But oh, okay, yeah. My wife just said we had an earthquake. I'm not sure. Might have just been me stomping my foot. Oh, okay. So anyway, hopefully we don't have a bigger earthquake. One in Truckee. Okay, so anyway, let's take a look at the circuit board, and I'll find like this first set for you. I'm not going to find them all for you. I'll leave that to a bare board thing. Let me get this switched over now. So I'm going to stop the screen and go to which video source? That video source. But I'm going to move over here. Hang on. This happens to be, if you look over here, this is like the power cords coming in. So it's chip number 1, okay? And check that out. If you look here, I wish I could show the thing, but remember R120? There it is, R120. These are some of the capacitors here. And if you go back to that diagram, you can find these numbers. So, and then here's the 3 leaving the chip. So it's 1 going in on this side, 3 leaving. These are all 33.2 ohms or something like that. Now these are 0204s. I can't believe, if you look at these, they just look like there's nothing left of them and they're all fried. But you can test these, and they're 33 ohms. So you got to be careful testing resistors in line, because it could be that this line, so you have a line here, so I put the probe here. It could be this guy jumps over through these, I don't know, through capacitors, whatever, and comes back through the chip and back up and around. And so you don't know, you're just testing the resistor. It could have some parallel resistance, and so you never know on the board. But in this case, if you do test these guys coming into the chip, that 120 coming in and coming out of the chip, these are 33 ohms. So I kind of verified that when I was trying to figure out the boards and what was going on. So hopefully that will help you if you have to replace components, finding the right component to replace. And doing it. So what I'm going to do tonight is we're going to replace the equivalent of the 120, not on this board right here, on the chip we've been working on. That's giving me problems. That's another video. But so let's go ahead and do the soldering for that. I kind of have all the lights turned down, but it looks like it's doing pretty good. So I'm going to go back to this nice shiny new chip and look at this area, and I think it's probably okay. We can zoom into this. So let me do that. Let me get it all. Hopefully we're not going to be too close. So I looked for 0402. Is that what I got here? Make sure I got 0402 so I'm telling the right thing. It's supposed to say. I got 10,000 of them. Thick film resistors. Sorry, my eyes aren't as fast as they used to be. 0402, I saw it on there. So they come in this big giant ticker tape. And if you can imagine, here's the head of a pin here. That's the head of a pin. So it comes in this big ticker tape because they're off a manufacturing roll that's been used before. So what you see, the blur here, is just a piece of tape that tapes them on. So I'm gonna pull the tape back and pop one of these dudes out. You gotta be real careful. Hopefully they come out. There it is. Okay. You probably can't see it because it's out of the video. Oh no, he popped out. Good. So I have like 10,000 of these. I bought them for $9 on eBay. So once you figure out what you want, you can go look at the data sheets, make sure it's what you want, and then go to eBay. And there's a lot of used manufacturer rolls, like half-used stuff. And don't buy 100 at a time. You should buy 1,000 or 10,000, just because they're cheaper that way. If you buy 100, they're going to charge you a lot of money just for those. And probably if you do a lot of board work, you're going to run out. So here's that resistor right there. And if you notice, it does fit in the square, but this is the back side of the resistor, the bottom, what will go into the solder. And I hope to gosh my soldering iron works, because I haven't tested that on the new system I bought. But even though this is a little bigger, you can see that it lines up with those feet. It's debatable whether I want to put more solder. I think I'm going to spread some more solder on it just tonight, just to be sure. And I'm going to have to turn on this light. So hang on, I'm going to blind you for a second. Oh, I turned it off. That's right, I had it just turned down. Just a second. I'm going to turn up the light because I got to be able to see what I'm doing here. So, all right, so there's another view of it. I'm going to work cockeyed a little bit too. So I think the first step is, I'm not sure, this sticks on there. This is a real pain to get it lined up. But I'm not sure what solder they had on the board. I've happened to have replaced this before. So I'm going to use the same solder I use for the heat sinks. Maybe I shouldn't be. Maybe I should be using the solder that I use for the chip. However, I don't have any, gosh, I could put a little bit of solder paste on there. I'd probably end up with too much. I mean, we could do it that way. So you could either put a tiny bit of solder paste down here and use the hot air gun and heat it, and then clean it off and then make sure it's not too much. Or I could take the soldering iron down here with some solder and some flux and just kind of, look at my lovely tip. Yeah, it's time for a new tip. That's okay. Kind of looks like a Dutch shoe with the nose picking up. Anyway, I can, I could put some flux down there and feed some solder in and take the excess off with the tip. You see, so I've got some damage to the board here. I think I'm going to go find a video where I can repaint this or put some new cover on this. It's just I've worked in this area so much that it's wearing out because I'm still having a hard time getting this chip to sit. Still working on it. So let's, yeah, I'm not going to use, I'll use the soldering iron to do this. So let me get my soldering iron on. Manual. I'm going to use about, I'll go with 350. It might be too hot, actually. Probably is. I could probably do it less. Let me go down to 300 just to compromise. I just read something that you should be 80 degrees Fahrenheit or centigrade above your melting point of your solder. So let's try that. So I'm going to throw, I got to save this resistor off so I don't make, so I'm going to move him out of the way. Hopefully I don't lose him or I'm going to have to get a new one. That's why you buy 10,000, because you bump the board. In fact, I think I just lost him. Is he still on my finger? Yeah, I might have to go searching for him or get a new one. But let's prepare this. Oh no, I never got rid of him. So you guys are watching this on the microscope and I wasn't looking. So come on. Where are you? There you are. I'm going to put him on the white part of the board and hopefully I don't hit the board. So I'll be able to find him and bring him back in. Sorry about this. Okay. So I'm going to lay down some solder. It's probably the same solder I had before. So you might want to clean this before you do it. I don't like fluxing a lot when I place the element, but just because I'm going to do this. Now I have to find my solder. I haven't soldered for a while. And you don't want much. Gosh, there's probably enough solder on there, but let me clean this tip. Hopefully we got a good tip. I've been out of the solder business for what, a week and a half or so? It's been kind of crazy. So I've got the flux, I've got the solder. Let's see if we can, with my shaky hands, melt a little bit of this. Okay. There's some nice feet there. Do you see that? So I'm going to wipe off the excess on my tip so it's clean. And I don't think I'll use the soldering iron anymore. So let's turn that off. I'm going to use a hot air gun to put this puppy on. Now, concerning the hot air gun, if you notice the size of the chip, you see the size of my hot air gun? It's the smallest nozzle I can get. And I'm going to turn the air down as low as I can get it. And it's still going to be hard because my flux, when you heat it up, it just kind of turns like water and goes away. But if you can heat it up gradually, the surface tension on the solder will grab that chip and just sit there. And hopefully the chip will sit there, it's not bumped up. So see how sticky my solder is? I need to clean this up and put fresh stuff down. So let's do that. Get that done. Okay, let's clean you up. Where are you? Yes, just wipe him up. It looks like solder paste is like on there anyway. Isn't that crazy? It's clean now. Just wipe up the excess so we dry out. Okay. So I guess I'll do 350 on the hot air. I bet, you know, sometimes I have to turn it up hot, but you know, I had a gun that really wasn't working that well, so maybe not. So let me dry this up a little bit. It's at 450 now. Let me turn you down. My nice new hot gun. So let me just get all the alcohol off and then we'll come back. Actually, those little nubs that I did look pretty good. So I'm gonna let the gun run because we're not gonna spend, well, I'm gonna turn it off. All right, so next thing, I don't put a lot of flux on here. I've noticed that when the flux gets sticky, it blocks, the chip is so light, the resistor, it blocks it from getting on there. So I mean, like, I just don't put much on there. Kind of like that, I've had better luck. All right, now I'm gonna go, I haven't lost my resistor yet. Let me see if I can grab it with these. And I'm at a weird angle, but let's see if I can kind of place it near it. Oh man, that's close. So from there, I'm not usually that lucky. Actually, that's almost pretty good. It would probably line up. But I do, I do take a needle and I push it around until I'm happy with where it's at. Usually I don't pull it along the side this way. I usually always go at a 90-degree angle. You can do better. All right, so we're kind of close. You can kind of see the tip of the, where am I? You can kind of see the tip of the solder bubble here. So this resistor is laying off the side, but it really doesn't matter if it connects. Because it's laying that orientation, I should blow the air in probably from this side, and that's going to be hard, but I'll try to blow the air in from that side. So let me heat up my gun. That's weird. I'm out of practice on these like live trying to fix something videos, you know. All right, here we go. I'm going to try to wrap this gun around back to this side. You should see kind of it blowing a little bit, I hope. Yeah, see it's warming up. So I'm warming up the area. I actually spent some time to warm up that resistor before I actually drill in on it. Yeah, just you want to slowly work your way in. Now I'm on the wrong side. Hopefully I don't push it the wrong way, so we'll see. Just kind of, okay, so I'm on it now. It's going to stay, I think. So let me go back the other way I didn't want to go to because it's just more convenient for the video. So I wait till I make sure the solder melts so I see some shine. It looks like it slipped down a little bit. Do you see that? I'm going to try to move it up just to do that. So hang on. A different needle. I'll probably blow it and have to reposition it. It might already be stuck. Oh, that's better. Okay. I'm going to do that. Apply some more heat. It might have stuck itself. So now the game is to melt the solder. It should suck that resistor right in there. See it moving? So yeah, whoop, it just sucked did you see that solder pull it down? That's cool. It didn't really line it up right, but it sucked it down. It's kind of hard to see. It slipped down again, didn't it? Let's just get that molten. It might be on there, probably it is. Look how close that air been in. Flux is coming in, I see it. I'd like to see it really shiny on both sides. I just don't see that yet, so I might not have gotten it yet. Usually sit there and heat it till it's shiny, and I know sometimes you see the resistor just plop down when the solder's wet. That's what I really like to see. It depends though. It might be on already. I just don't know. So I usually do it a little hotter. Turn up the heat now, see what happens. It's not going to hurt the resistor any. Up to 415. It's going up there. If I heat it too much, I don't know. There it goes. Do you see that? We got it melted. So there it is. I was at 415, but I slowly heated it up. So I'm going to turn the air up on this gun. Trying to, you know, these soldering guns are made so that you put them down and they shut off, and I don't like that. But when you have that small tip on, it does not cool off fast. So you want to turn up the heat. So it's just like blowing as much air through there as you can on that small tip. All right. So there you go. That resistor is good. You'll want to after it cools off, and I think it's cooled off for the most part, get the flux off, you know, clean it off, and we should have it good. But hopefully you saw that guy plop in, which is what you want to see. Doesn't happen all the time. Capacitors, when you start, see, I messed all these up too. I'll show you. I hate to admit this, but there's 3 other capacitors that are missing here. Sometimes I try to do 2 at a time, but I've got a capacitor here, and a capacitor here I have to replace. This guy, for some reason, wanted to stay, but I really kind of screwed this one up. So I got to go back and fix all this damage, and so that's why I buy a lot of those parts on eBay and try to get those going. So anyway, I think that's what I've got for you tonight. I hope that helps the person that asked about that. Please join that Discord channel. It's much easier for me to talk to you there, answer your questions. I can put files on there. I can take pictures and put on there. And YouTube, it's just like I hardly get notified someone asks me a question. So better off for conversation. You can watch a video on how to do Discord, but it's just a chat. It's what gamers use. I'm not a gamer, but I could be. I just a long time ago had to go to work and stopped. However, don't have anything against that. It is a great platform. Discord's a great platform for this. So please join. I think we'll have some great conversations, and I hope this video helps. And be sure to subscribe and hit that bell. Thank you very much.